All right, welcome everybody to a whole new week of Computer Science 40. So we're going to do something a little different today. Between Lecture 1 and Lecture 2, the 12 o'clock, the 2 o'clock class, they're going to be kind of combined to actually solve a real-life application. So first of all, if you have any questions about the image processing assignment, please ask now or forever hold your peace. They will be due on Wednesday. And I did mix up some of the groups. Some people went AFK, they didn't respond to their partners. If your partner tried contacting you and you never responded to them, there's a good chance that you have a new partner now. All the AFK students were put into their own groups so that they could AFK together. And usually the way these things go, about half of them are just like complete zombie students that have dropped the class but haven't dropped the class, I guess for units or financial aid or something. And then the other ones are students that will like wake up at midnight on the night before it's due and be like, all right, so what am I supposed to do? And so all those students get to be in the same group with each other so that they don't affect the students that start earlier. So I did watch Dune last night, or 2 nights ago. Pretty good movie. Highly recommend it. This isn't Dune, but it kind of reminded me of it, so I set it as my background. Okay, so the problem that we're solving is one that I've actually solved in real life. But the problem that I'm solving right now has to do with the fact that I've got, every week, Walker, who you've probably seen on Discord, he wrote a bot, and the bot monitors my CSI 1 students. In CSI 1, it's critical thinking. You have to participate. You have to say things and engage with the class. You can't just like watch critical thinking. You have to do critical thinking to learn it. So the Walker bot watches people talking on Discord, and once it's decided that they have contributed enough, it will send them a message saying, you're good for the day. They have to contribute every day of class, which is a 48-hour period, right, between Monday and Wednesday, Wednesday and Friday, Friday and Monday, which is 3 days, I guess, not 2. They have to participate every day. And every day they participate, it sort of makes a notation. And then every Monday at the start of class, it mails me the roster of every person on Discord and how many days they contributed between 0 and 3 during that week. And so what I've had to do is every week I go onto Canvas and I have to play a game where it's like a riddle. I've got like some Discord name like that. These aren't real names. I'm not showing the real student names because this is going up on YouTube. Yeah, but then I get to be like, all right, who's that? And then I go onto Discord and I search for, Jones, and I'm like, all right, there's 3 Joneses. All right, is there another Jones in the file over here? Oh, there is another Jones in here. Okay, that's E. Jones. And so we got an Ephraim Jones and like a Bill Jones, and so that's probably Ephraim, and that one's probably, and I have to play this riddle literally every week with 90 students, where I have to guess what their real life name is from these Discord names that are sometimes just their name, and sometimes it is not. And we have a rule in this class: you have to have at least your last name in the username. Not everybody follows that. There's quite a lot of people who just go by their first name. And then I have to process all of those after I've handled everybody with the last names, because first names are more shared. And oh Lord, it's a pain, because there's 94 students in Computer Science 1. And I kind of brought this upon myself, but it's really important that CSI students, CSI 1 students especially, participate on a daily basis. So what I want to do is import these files, which look like something like this. I have a bunch of them, one for each week. And I just made up these names. Again, these are not real names. And I want to combine them together, like so I can do multiple weeks at the same time, right? So if I've got here, I've got here 3 different files. That's the first file, that's the second file, that's the third file. Cat, by the way, is a program that concatenates files together, so it just prints all 3 of those files together as one file. But I'm just basically, cat is very useful. It's just like if you just want to quickly view a file, you just cat it and it just appears on the terminal. For short files, it's a really easy way. You don't have to, you can defend it, I guess. But then you have to like vim each one of the files. It's kind of slow, so just catting all of them is nice. And you can use a wildcard like that, and it will find all of them, all of the file names that start with week and end in .text with anything in between. That's called a wildcard character. Saves you a lot of time. If you have ever done something repetitive in Windows with a mouse where you've got to like rename 1,000 files, like you got your photographs or something and they need to be renamed in a certain format, and you did them one at a time, just be aware there's a reason why experienced computer science people like using the command line. And there's a reason why I recommend all of you do the Unix tutorial. A lot of people haven't, and those are the people that are oftentimes having to ask me for help because they're like, I don't know how to do this. And it's like, you know, I understand it's optional. And as a student, you know, anytime a professor tells me something's optional, it's like, I'm not going to do it. You know, but in this case, learning Unix is going to really, really help. It will, the hour or two it will take you to do the tutorial will more than pay itself back in spades, just in this class alone, let alone all future computer science classes, which do require you to know Unix, and in your professional career as well. It is one of the single greatest things you could do to improve your time efficiency and in life is to learn Unix. At some point, we are going to get a Unix lab class here at our school. The pandemic kind of threw a wrench in it, but one of the reasons why we hired Lawton, you know, our new computer science professor, is so that we can start offering like a Unix lab and a database class. And Lawton himself he wants to do like app development and like, you know, some other things. So data science, maybe, we'll see how that goes. So okay, so right now, so we've got these text files that has no tab delimited data or anything like that. It's just a bunch of words, maybe some emoji, just spaces, and the very last thing is a number. Okay, and so in the previous class, I showed them how do you open a bunch of files in Unix, in C++, really. How do you open, like we have 3 files here, right? We got week 1, week 2, week 3, and we want to read all of them in. And every time somebody has a name that appears again, we want to update their attendance count, right? So if Big Honkin' Jones showed up 3 times on the first week and 1 time on the second week, that's 4 times total. And he showed up 3 times on the third week, that's 7 times total. So what we want to do is create a vector with basically people. We want to have a vector containing people, you know, and that's why classes are important, because there's a couple different things here. Like just on the screen, we've got their Discord name and their attendance count, but I also want, and this is the part we're going to be doing today, is I want to tie this to their Canvas names, so I don't have to play the riddle game every week where I'm like, who is this? Who's Princess Jasmine? You know, like, so what I want is to find, okay, Jasmine is referring to Jasmine so-and-so, and I want to, one time in my life, have to enter in, given their Discord name, it'll be like, hey, who is this person? And I would type in, this is Jasmine Jones or something. Boom. And it'll save to disk, and I never have to do it again. And probably also their student ID. Okay, because sometimes people will have the same name, and student ID is the only way you can disambiguate between them. Do you guys understand the problem here? And this is a real life problem. I've actually been paid money to do this in real life. There was a school district that had this is an annoying problem for me, and they had an annoying problem for them. They were giving workshops for K-12 history teachers, and professors would come in and they would give a workshop, and the teachers didn't have to attend all of them, but they had to attend at least like 30 hours or something during the year of training. And if they attended 30 hours of training, they'd get paid a check for, I don't know how many thousands of dollars, quite a lot. If they didn't attend it, they got nothing. So it was really important that the attendance be done accurately. So every time they came to a workshop, they had to sign in. If they didn't sign in, sucks to be them, right? The people running the grant would type the sign-in sheet into Microsoft Word or something, and they basically just had a bunch of files saying, Tim Jones was there on this day, and so they had all these files, and then at the end of the year, what they were having to do was go through each participant and go Tim Jones, and they would search through the first one, be like, yes, and they would highlight it. And then they would have another file that said Tim Jones and write down, okay, that was a 4-hour workshop, 4 hours. And they'd go through the next one and try and find Tim. And then they would add 2 hours to that one. And they did this for all 20 workshops or whatever. And it was a complete pain because you had 100 teachers in the program, right? 20 workshops. And if you missed any of them, then they didn't get paid and they get mad, you know, like, why didn't you pay me? Why didn't you pay me? You know, oh, we missed the one thing that dropped you below the cutoff. Sorry, you know. And they're like, hey, you know, it'd be really cool if you could just write us a program. So I'm like, all right, pay me $5,000 and I'll do it for you. And they're like, sure, we'd love to. Because, you know, you'd figure out how much time they were spending on this. Like, it was like, I don't know, a couple thousand probably a year, you know, on this. And so it's just begging to be on me. Exactly. And so I made a little web interface and they basically just, I'm like, hey, show me what your files look like. And they showed me what their files looked like. I'm like, okay. So I just put up a website that just had a big blank text box. They'd go into Word, Control A, copy, go into the website, paste. How many hours was this workshop? 8. Submit. And then my thing would go through and do this. It would split everything up and it would find that. It would add it. I had a database that tracked each teacher and their total hours. It was basically pretty simple. And every time they would paste a new record in, it would find if they existed already. If they existed already, it would update their hour count. If they didn't exist, then it would create them and add in the hour count. And they would just, all they had to do was copy and paste in their 20 files. And then they would hit a report button, and the report button would print out all the teachers that made the cutoff and all the teachers that didn't. And they could look at it, and because sometimes if there was a typo, like if sometimes, you know, Bill would sign in as Bill and sometimes as William, then Bill gets 20 hours and William gets 20 hours and neither, but it's the same person, right? So you have to kind of like look at it a little bit and be like, okay, that was a mistake, you know, and I had some functionality in there to like help clean it up and stuff like that. But basically that was the thing. I got paid $5,000 and it took me an hour or so to code and a couple hours of testing, and you know, it's just making sure that it was rock solid, it wouldn't crash, it wouldn't dump the records accidentally, you know. It couldn't. It had a login system so that random people couldn't corrupt it, and you know, stuff like that. But it's basically about an hour's work. So that's basically what we're doing here. So what we did in the previous class was the reading of the files. So we've got all these files. They look like this. Just no tabs. Nothing helpful like that. So it's just a bunch of words, and then the last word is a number. And so there's a couple different ways we could have done that. But I'll show you what we did. But first of all, do you guys understand how we need to make a class, right? We need to make like a class for a person. You guys understand that? Because we're going to be holding records for a person. What kinds of things describe a person for this application? Not for other applications. We don't need your social. We don't need your street address. What kinds of things describe a person for this particular program? Discord name. Yeah, that's a good one. Sure. What else? Days attended. Sure. String. Okay. It's fair. It's fair. Okay. All right. There we go. And attendance. So we have their Discord name, their attendance. What else? Begin date. I'd probably just wipe the database. That's what I did. that's what I did before, right? Every year I'd just go in and be like, purge, drop the tables, you know. Actually, I'm going to drop the tables. I just delete all the records. Delete from, you know. So I think I probably had a button in there to reset it so they could do it. So at the beginning of the new school year, bloop, click, drop all the records and delete from, you know. Canvas name, yes, exactly. String canvas name. But here's the kicker. I want it sorted by last name. right? So canvas name is actually a first name and a last name, right? So I actually want first name and last name, right? Because I'm going to sort it based on the last name. All right. Anything else you can think of? Student ID, yeah. Because sometimes you can have two students with the same name, and the only thing that separates them is the student ID. I actually have, I put notes in Canvas to myself anytime I'm entering somebody whose last name is the same as somebody else's. I manually put a note in there with their student ID, and I check that against their username, because the username has their student ID in it. Just so I don't give the wrong score to the wrong student, which, you know, does happen sometimes, but they usually notice. Which class, 12 or 2? CSI 1, I combined all the sections on Canvas. But yeah, that'd actually be good if I had 3 different Canvas, you know, things to click on. Then I would have to like click on one and do all the teniums. I would probably do it that way. Yeah, just like you said. And then I would sort it by 8am section, 9am section, 10am section. And then within the 8am section, I would sort it by last name. And if the last name's a tie, sort it by student ID, probably. But as it is, I've merged the sections together, so I don't need to do that. One thing that... now, you might want to make the argument, like, well, what if in the future you need to do that? Then I would say, well, then in the future, I'll do it then. One of the, you know, it's important to think about the future. It's important to think about like what could happen with your program. You know, what changes might get made at some point. But it's also important not to over-engineer. Like a lot of people spend a lot of time worrying too much about what could happen, and they build these really complicated things that don't work very well because they're so complex you can't really debug them fully, and they sort of break. And in the previous class, I gave an example of a friend of mine who wrote a complete state machine simulator that would have transitions. It's in this state, it would and he made his own language to describe the finite state machine. And I used an integer and some if statements. I'm like, I'm in state 1 right now. Now that I've logged in, okay, I'm in state 2. I had some constants, so it was like logging in state, logged in state, transmitting state. I just had, you know, there's like 5 possibilities. Logged out, you know, normal, logged in, you know, and I just had an if statement. Like, if I'm in this state, then do this. And he built this entire, he's like, this looks like a state machine. I'm like, it is, but, you know, I just used an if statement, man. Like, I don't know what to tell you. Yeah. If the packet comes in and I'm in the logging in state, then I have if my state is logging in, then do that. And he built this 30,000 line finite state machine simulator, and he's like, but just think about in the future, if they add another state, I can just add a state to my finite state machine simulator. And I'm like, I can add an if statement. And we're not going to, because this is a class. Classes, you write a program, you submit it, and you're done with it. You never see it again. You know, and that's one of the reasons why we're going to do Pokemon Part 2, is because you get to build on your previous work. You know. So. Okay, so yeah, this is a good class for a person. Let me save it now. All right, so let's take a look at what we did in the previous class. So yeah, there we go. And I wrote a friend function to print it. All right, same pattern we always follow. Friend, ostream at, operator double left arrow, ostream outs, const person, blah, blah, blah. And it just prints out their name, tab, first name, tab, last name, tab, student ID, tab, score, which is their attendance, tab. And the reason why I'm outputting tabs is because I'm going to be using this double left arrow operator to save it to disk. And when I'm saving it to disk, I want it to be in tab delimited format, because it's way more annoying to deal with it if it's not tab delimited. Okay. So so this we do in your image processing assignment. You don't have to worry about it. I did it for you. But what it says is how many command line parameters you have. So if you're curious what these things mean, so argc is how many command line, argument count is what it stands for, argument count. So if you just run it by itself, the argument count is 1. It had 1 command line parameter, and that command line parameter was a.out. If you say a main whatever, then it had 11 command line parameters. So it's a count of how many command line parameters you type on the screen. This is how you connect the command line, the Unix prompt, with your program. This is how, like, when Vim says vim main.cc, the Vim knows which file to open. If I ran this, its argument count would be 2. The first argument is Vim. The second argument is main.cc. And so the arguments are passed in as a array of char stars. And that is kind of like that, I guess. It's an array of character stars. A char star is a C-style string. And so if you want to see what all those things are, you can say for int equals 0, I is less than argc, equals plus cout arg v square bracket I. So this will say for every argument in the argument count, print out that element of the array. And so it's just an array of strings, C-style strings, which you should never use, but you have to because that's how it works. The argument parameters have never been updated to have strings. So they actually get passed in as char stars. Okay. So this will print out all of the command line parameters. So we say a.out, text 1, text 2, blah, blah. Then the first command line parameter is a.out. The second one is text 1. The third one is text2.text. Okay. You guys understand that? So that's what those things mean. And it's pretty common to, like, if your program requires you to type in something, to do something like this. Like if you didn't pass in enough command line parameters, print out a usage. Like this is how you run the program, you know. And that only be used with main. What do you mean only used with main? Oh, these things? Yeah, main is the entry point into your program. And so that's where the command line parameters get passed in. So the command line parameters get passed from the operating system to your program. Main is the interface. That's the interaction point between the operating system and your program. And on the back end, you know, when you return 0 or whatever, that's returning an error code back to the operating system. Yeah, so these things only appear in main. They don't appear in other functions. And if you don't put anything there, then it just ignores them. Okay. So we made a vector of people called database. This is all the users in our system. Big Jones, or whatever his name is, Princess Jasmine, they're all going to be held in here. And then I'm doing something a little weird. I'm actually adding a dummy student to the system called error. And the reason for that is because of this thing here. And so have you guys seen Unordered Maps before? Have we gone over this before? How they allow you to associate, in this case, a string and an integer together. Okay, so let's go over that real fast. See if that works. Okay. So an unordered map works, it's called an associative array. And so you can do something like this. You can say map January is equal to 31. Normally, square bracket doesn't take strings, right? Normally when you have like a array, you can only put an integer in there. Index 5, index 10. In this case, the index is January. Okay, so what this is going to do is set the value of January to be 31. And the value of February to be 28. The value of March to be 31. All right, so you can, and this will come up for your Pokemon assignment too. You do the type system. It's kind of important. So if you ever want to then print out how many days March has, you can say cout March has map square bracket March. It's case sensitive, of course. You guys see that? So it works like an array, but it associates what's called a key and a value. That's the key, January, and the value associated with January is 31. The key here is the string February. The value associated with February is 28. And you can just do it like this, and g++ main2.cc. And you see that March has 31 days in it. Kind of cool, right? In a lot of languages like Lua and JavaScript, Python too. Yeah, I mean, there's a reason why we don't use square brackets, but in this case, we're gonna handle it anyway. Do you guys see how this works? So we can simply associate a value with a certain key. Bell, everything in JavaScript is an associative array, right? We do arrays in JavaScript, sorry. Yeah. Okay. Do you guys understand this? Okay. Now, here's the downside, and this is why Mr. Bell said, "Ew, square brackets." There is one very gigantic sharp edge in the Unordered Map class in the standard library, and that's if you try reading from it a key that doesn't exist. It adds it. It adds that key for you. So if you say cout April has not only is this going to print 0, it's actually going to add an entry for April and insert into the associative array 0. April has 0 days. So it seems like a class. Yeah, the unordered map is a class that basically takes as input a string and gives as output a integer associated with it. So it's a very, very, very useful thing, by the way. These things are highly useful. Probably the most useful class you will ever encounter in your life. Unless you write your own, in which case you're still using it. So if you ever want to print out all the things in a unordered map, you can do something like this. For so the hash table is a combination of a string and an integer. And so when you say, give me all the values in the map, it gives you a pair. The first value of the pair is January. The second part of the pair is 31. And then the next key value pair is February and 28. And the next one is March and 31. So you get the first part of a pair like this. Key value first. So the first part of the pair is the string part. So that's going to be the name of the month. And then the second part of the pair is called second. So if we were to output, the entire unordered map, you can see here it's not ordered. You see that it's not sorted. That's why it's called that's why it's called an unordered map. So, but that's the whole map right there. It's got a list of all the different months and how many days are associated with it. On a scale from vectors to arrays, they are the fastest data structure for inserting, searching, and deleting. They're not good at keeping an order in things. Like if you want to simulate a line at a movie theater and you need to know your first in line, your second in line, your third in line, a vector works great. There's a data structure called a deck that's even better because you can take people off the front of the line. Unordered maps don't hold ordering. So if you need the order that people came in, an unordered map doesn't help you. But in terms of speed, they are absolutely the fastest option there is. Okay. Use a queue. Mm-hmm. So now watch what happens, though, if we move these lines below here. So if we run this code here, you can see that there is now an entry in the unordered map for April. So not only did it look up how many days April had, it added it to the database. And this is a gargantuan sharp edge to worry about with unordered maps. And so what I'm doing in my code is I'm just detecting if 0 is ever returned, because and that's why I put a dummy student in there at index 0. So if I ever get, oh, that's student 0, I'm like, that's a new one. We've never seen that person before. You see what I'm doing there? So I add a dummy element to the vector because the unordered map is going to be holding. The unordered map is going to be holding. If you pass in a name like Bill Kearney to the key, it's going to look up where in the vector Bill Kearney is. So the integer here is not days of the month; it's where in the database, which index in this database Bill Kearney is. Okay. So you pass in Bell, and it's going to return Bell is at index 5. You pass in Mincarelli, it's like Mincarelli is at index 10. But if we ever say, hey, where's Mincarelli? And it's like index 0, then we know that Mincarelli is not in there right now. But that's why we have to do this ugly hack. And there's better ways of doing this too, by the way. You should not consider this the best method of doing it, because it's certainly not. But it works. So, yeah. Does the unordered map print out the indices at random? Yeah, it's unordered. You don't know what order it's going to come in. We got March and like who knows? It's unordered. When you print them out, they don't come in any particular order at all. Okay? So I'm doing this ugly little hack here because if we ever try looking up OTAL, what index is OTAL in the database here? If it returns 0, then it's like, oh, never seen that guy before. And so then I add them and fix it. So all of this code here, you're going to want to watch the 12 o'clock lecture to see how I did this. This is all up until here, just parsing the file. So this is basically the same approach we took towards Pokemon. So for every file in the argc, the argument count, so we can open up 3 files or whatever at once. So for every file we're told to open, we open that file. If we couldn't open it, we die. We then read that file. We read one line at a time out of the file. If we ever hit the end of the file, we break. We turn that line into a string stream. We then split that string stream by word. So we read from the string stream words over and over and over again and put them into a vector of strings. And so if it's like Bill Kearney 3 as the 3 words in it, the first element in vec will be Bill, the second is Kearney, and the third is 3. If it was a blank line, we ignore it and move on. If the last vector.back is the last element in the vector. So if the last element in the vector, if its first character is not a digit, because every line of our attendance file is supposed to end in a number, right? So if it doesn't have a number in it, then we just ignore it and move on. That keeps us from crashing on Stoy, right? Stoy will throw an exception and kill our program if the last thing is Kearney, right? Like if we forgot to put a number there, it would throw an exception and kill our program. So if we don't have a number at the end of the line, ignore it, continue, move on. Okay. We then pop back, so that deletes the last word of the line, which is going to be the days they attended. And so what we end up with now is a vector containing each entry in the vector is William, Jones, Bob, Kearney, right? 4 elements in the vector, and then we join them back together using spaces, throw away the trailing space, and now we've got a name. So we basically take a line, we split it by spaces, take the last word, convert it into a number, throw it away, take the remainder of the string, combine it back together into a name, and we're done. So this was kind of an annoying bit of parsing. This is why I like doing tab delimited files much better than space delimited, because you have to do nonsense like this. Okay, so you can see the process by watching the 12 o'clock class. Then at the end of the day here, what we're going to do is we're going to look up that name. So we've got a name, like Billy Bob Joe Thornton as the name. One string holding Billy Bob Joe Thornton. We look up, that's the unordered map. That we're looking up if we've seen them before. If it returns 0, we've never seen them before. Right? If it returns 0, we've never seen them before. So we say if it returns 0, then we put them into the lookup table. So we write into the entry for Billy Bob Joe Thornton. We're going to say Billy Bob Joe Thornton is at index 5. And how does it know what index in the vector it is? Well, if the vector is empty, if the database is empty, it's going to, when you call pushback, it's going to write into index 0, right? Like if the vector is empty and you call pushback, it goes into index 0. You guys with me on this? If you have a completely empty vector, call pushback, it goes into index 0. And then if you push back again, it goes into index 1. If you push back again, it goes into index 2. So the index that it's going to go into is just the size of the vector. If the size of the vector is 5 right now, the new one is going to go into spot 5, because if you have 5 right now, they go from 0 to 4. So yeah. And so the lookup table again is just holding which index in the vector the different names are. And the reason why I'm doing this is because it's much faster than calling find over and over on a vector, because find has to go through the whole damn thing. A hash table does it in a single operation. So it can find, it's essentially, we technically don't need this unordered map, but it makes things way faster. And when you guys do your Pokemon 2 assignment, you're going to probably be using an unordered map. Like, they'll pass in fighting type, and you have to figure out, okay, which row is fighting type? Which row is psychic type? You're going to use an unordered map for that, probably. Unless you don't want to. Okay? If you don't understand it. So do you guys understand what's happening here? So we're going to put into the lookup table, Billy Bob Joe Thornton is at index 5. And then the next time we see Billy Bob Joe Thornton in the next file, it'll return 5. Like, oh, okay, cool. We know where he is. And then we just go to that location, 5, and we take their score and update it based on attendance, which is how many days they attended this week. And so it's just going to combine all of the records together and add, that line right there adds all of their attendances together. And so if we run the code and we say that, so Big Honkin' Jones has attended 7 days, Princess Jasmine 6, Fidel Castro 6, Big Habit 6, Old Bailey 5, E Jones 3. And if you look at the files, you can see here E Jones attended once, twice, 0. So yeah, so his attendance is in fact 3. So that is that's the first half. Now the second half is going to be associating this with Canvas, the Canvas username. Okay, so there's a couple different ways we can do this. The easiest, and we're going to need to also write this to disk. So the first time we encounter a new student we've never seen before, what we're going to do is just ask the what is the first name for user Discord name. Okay, so we're just going to ask the user of the program, me. Hey, if somebody's name is Big Red, you know, what's their real life name? First name, last name. Okay. And so we're going to do first name, last name, student ID. So we're going to ask me, and I'm going to go into Canvas and find who each person is. And it's going to be annoying, but I only have to do it once. Right. Okay. So what is first name and last name? Okay. And so then we're just going to make a string first name, last name, and student ID. And so we're just going to, and these should just be single words, I think. So I think we just use double right arrow. So we're going to read in first name, last name. Student ID is also a string because somebody, I was going to do an int, but somebody pointed out that the student IDs are technically not ints because they have a leading 0 as part of them. They're actually strings, so that was a good point. So we are going to, when we add them to the lookup table, we're going to put in the first name, the last name, and the student ID. And so when we add them to the database, we now have a full, complete student record there. And then if they already exist, we don't have to mess with any of that stuff. If they already exist, we know what their deal is. Okay. So let's do this. Let's see what we got. What is first user? It's going to be Nero. Its last name. Student ID 1. First name for Jasmine is Min Pirelli. Last name is also Portnoff. Student ID of 2. Fidel Castro is Gustav. Last name. Student ID 3. His name is Big, actually. His last name is Habit. Look at that. Student ID is 4. Old. Mini board here. Bailey 5. E. Jones is E. And Jones. Student ID is whatever. Okay. And so you can see here that when we dump the, I have some code at the very bottom that just prints the entire student database. You can see that, sure enough, it worked. We got their Discord name, tab. First name, tab, last name, tab, student ID, tab, and then their attendance count. So what we want to do now is dump to disk this. So this code here, we want to write that to disk. And then the next time we launch the program, we want to load that from disk and pre-populate our database with all the users we've seen before, so we don't have to enter their names and stuff, but we want to clear their attendance. So the next time we run it, because we're going to have week 7 and 8 and 9 or whatever, we don't want to use the previous ones' attendance because those have already been entered into Canvas. So what we want to do is when we reload, we want to set the attendance to 0 and then do our thing. You guys have any questions about what's going on with this? Do you guys understand the the application? Like we got all these files, and what we want is to add together the 3, the 1, and the 3 to come up with 7. So we want Big Hawk and Jones to say 7. He's attended 7 days. Oh, Lord, I don't want to do this again. Okay, so Big Honk and Jones attended 7 days. Okay. All right, so let's write this to disk. So rather than... You're good? You understand? Okay. So rather than printing it to the screen, what I want to do is just write to the student database file, which doesn't exist yet. So let's make one. What's a good name for a student database file? What do you guys think? cheese wheel. Students.text. Okay. All right, so that'll hold our official record of all the students. And so when we launch, we're going to read from it. But before we do that, let's write it first. And so what we're going to do is we're actually just going to do this. We're going to make an output file stream, outs, opening up database file name, outs, die. So if we can't open it for some reason, we don't have permissions, die. db studnuts. So rather than printing this whole thing to the screen, watch this. We're going to print it to the file. And the lookup table, while interesting, the lookup table is just telling me which index each of these people are at. So Big Honkin' Jones was at index 1, E. Jones is at index 6, Fidel Castro is at index 3. That actually doesn't matter. That's the reason for that. The reason why I was printing that was because I had a bug in the code, which you can observe if you watch the recording from 12 o'clock. You can see the bug that I had and the process I went through to find it. It's probably pretty interesting. So, but we actually don't care about that in the slightest. So I'm just going to comment that out. And let's see what we got here. A, B, C, D. Students.text, so we got Big Honkin' Jones, ABC. The thing we care about is that Dab for Princess Jasmine, 6. Okay. So, good, we're writing it all out. All right. Cool. And probably we could do something like that. So we don't p dot, was it Discord? So if the name's not error. So we're not printing the error because we don't need to. That commented out bit, was it a bug? The only thing I've commented out right now are the cout statements, and that was all just used to figure out where the bug was. So, like I said, for this, you probably watch a 12 o'clock class and learn, the process of making something like this, because yeah, there's a bug in it, and it mystified me, and then I used the power of couting everything to figure out exactly which line was going wrong, and identifying it and fixing the problem. But there was definitely a moment where I was just like, what? Huh? What do you mean? Huh? Hmm? And it came about because I used vec for everything, and I forgot that I'd called my database of students database, and I used vec instead of database. And so I was getting the size of vec instead of the size of database. And so all the indices were going to the wrong place. Yeah, it was a fun little bug. None of the commented out stuff is a bug. These are all just cout statements. And it's a very powerful technique to find stuff. For other problems, a lot of times using address sanitizer is the right way to go, or using a debugger is also. You got to just have a bunch of tools in your toolbox, your tool belt, and just be able to bust them out to debug. Because the single greatest thing that kills productivity in this class is when students have their code not working right and they can't figure out why. And it's something I hammer over and over again. You need to be able to figure out yourself why your code's not working right. Print out all the things and see if what's being printed matches what you think it's going to print. If it doesn't, then you can figure out, okay, it's that line that's going wrong. I'm calling sort, but it's not sorting anything. Why? Well, I said from vector.begin to vector.begin. Oh, wait, that's wrong. Okay. So now we need to load this into memory. All right, so right around here. So input file stream, call it, we call it ins. We've got another ins down here, but they'll shadow each other. Not a big deal. I don't care. I don't care. All right, you're called database file name. If not ins. So if we can't open it, that means it doesn't exist, and that's actually fine. It's actually fine if it doesn't exist, because the first time we run the program, it won't exist. It's fine. So, if it doesn't exist, we don't need to do anything, I think. Yeah. But if it does exist, then we're gonna load from it. Okay. So let's make a double right arrow operator here. 2, 3, 4. 4 lines, Y4Y, Shift P. Oops, what happened here? Undo. Hello. Why is undo not working? The hell? Okay. D4D. Okay. Try this again. Y4Y, Shift P. What the hell? Oh, I have caps lock on, which is the single greatest enemy of Vim users. Okay. Really, it's a good idea to just turn off caps lock, honestly. Or people bind caps lock to like different things. So we need to do a double right arrow operator. Or you just bind caps lock to nothing, so it just literally has no effect. So double right arrow, iStream. This can't be a const. And you're not an output stream, you're an input stream. Change all, turn the frowns upside down. Actually, we can't do this, can we? Yeah, because it's tab delimited. Okay, so let's do this. P.discord name equals readline until a tab. So we're going to read from the file until we get a tab. And then the first name, read until we get a tab. Last name, read until a tab. Student ID. Read until tab. And score is an integer. So that one we are going to temp. So we're going to read until a tab, and then we're going to stoy it. Yeah. So p.score is equal to stoy temp. And hope if that doesn't read, well, we'll find out real fast. Shadowing, is that what you thought you were doing when you used the name vec for everything? What a magical world when your data is reading, properly formatted for reading. Yeah, well, I'm writing it. I'm writing it, so I can be damn sure that I'm reading it properly. But yeah, I probably should do some error checking here. If it's not, I'll find out. It'll throw an exception, and I'll get to debug it. But we'll just see if this works. This is highly optimistic, but yeah, we're gonna read. This reads from a file, and it's gonna read until a tab, and read until a tab, and read until a tab, and the integer here, it reads until a tab, and then converts it into an integer here. Okay, so what are we gonna do? So if the file exists, then we're gonna make a person p, and just gonna read that. If we hit the end of file, we're done. Otherwise, we add them to the database. So database push back. Okay. So what we're going to do is we've got this database on disk called students.txt. We're going to open it up. And while there's data remaining, we're going to read one person at a time. If you try reading a person and you hit the end of file, it'll throw an error like that. you check it, break. If an error didn't occur, then we add the person to the database, and then before we do anything else, I just want to see if this worked. So I'm going to say for every person in database, I'm just going to print them out. And then I'm going to quit. You see that? I'm just going to print it out and quit. Because I don't want to do the rest of it. I just want to see if the loading works. And this is very common. Like, we talked about drivers and stubs and things like that. And so if I want to test a little bit of code, I will have my main just call that little part of code and see, does the load work? If you're making a video game, you need to serialize the state of your world to disk. Then rather than running your game and running around, shooting demons and stuff and hitting save, no, you just make a little driver that calls the save function. You look at it, okay, that looks fine to me. Then you make a load function and you just have your main just call the load function and see if the data you get back matches the data you saved. And if it's not, you can, like the idea is when you're doing development, you want to just isolate the little bits that you're working on. Okay? And then don't run the whole damn thing, just isolate. Okay. And there you go, $5,000. Yeah, it's a little bit more than that. It was SQL calls and stuff like that. But yeah, it's basically the idea of it. Okay, so when we run it, weak star. Aha, Stoy crashed. All right. All right, so now we get to debug it. All right, you guys, it'd be boring if everything worked right. All right, so let's see out all of the things. See out p.discord name. Let's see what we get. Let's see what we got. I bet it's the last line that it's actually causing the problem. Yeah, there we go. The last line is crashing it. Okay, yeah, makes sense. So let's see if this works. So Big Hong Hit Jones A7 student text A7 Princess Jasmine A6. Okay, yeah. So everything was working until that last line. Why? Because there was a blank line at the end of the file. So Mr. Bell's worry was legitimate. So, if temp.size is greater than 0 and is digit temp.at 0, then we set it. Otherwise, because I don't like having uninitialized variables, is equal to -1. So if we ever see a -1, we know something went wrong, because you can't have negative attendance. Okay, everything works. So we got our error in there. If you guys ever saw Zelda 2 I am error, there's actually a NPC in Zelda 2 who just tells you I am error. That's Mr. Error right there. Okay, so now we're reloading the thing. Now if we update our students.txt, let's see here what's going on here. Now the reason why this didn't do anything, like I was expecting it to have the new attendance added on, and it would be essentially doubling the attendance records every day. Now, technically, when we load it, we don't have any attendance, right? Because we're kind of starting a new week. So let's actually come in here and we're actually going to set the person's score to be 0 because we want to reset their attendance each week. And then the other thing we need to do, the thing that we forgot, is to write down in the lookup table what index the person was in. So the lookup table, score bracket, person's Discord name is equal to database.size. So save where they are in the database in the lookup table. And again, you don't need a lookup table like this. It just makes everything faster because you can look up what spot they're in a single operation. Whereas if you did find every time you did anything with any student, you'd have to go through the entire database of students looking for them, and then you'd immediately forget where they were, and the next time you do it, you have to go through it again. And so with the lookup table, we're just sort of writing down, okay, Bob's at address 7, and Min Crowley's at address 12, and I'm at address 17. And so every time you add somebody to the database, you just write down on a little scratch pad where they were, and then if you ever need to find them, you're like, oh, okay, where's Kearney? 17. Okay, cool. So lookup tables, very nice speed optimization. If you have a million names in your database, it'll run 1,000,000 times faster. So that's nice. That's nice. However many people you have, that's how many times faster it'll run. So with that, oh, and we're not doing the code, of course. So let's just run it one more time. Just make sure that we're clearing out the scores properly. And there we go. So all the scores are getting cleared out. Okay. All right, so let's pull this out and get you out of there, and let's run it. And we're good to go, I think. Nothing gets output. Cat students.txt. You can see that we got all the data in there. So it's working. And then all we need to do now is anytime there's a new student, I need to just look up their name in Canvas and punch it in. I'm not going to delete the students.txt file ever because it's going to have all of their names and last names and stuff like that in it. But the weekly data, like this data here, that data is going to get erased every time. But the students.txt will be permanent for the semester. And when the semester's over, throw it away and move on with my life. Should still list to the DMV. Yeah, the reason why the DMV is so slow is because the only explanation I have is they don't do something like this. If you ever have to look up your information in the database, they hit return, and then it goes to a mainframe and it goes through every record in California, as far as I can tell. It goes through all, however many millions of people live in California to find a match on your records. Whereas if they did something like this, they would be able to go bloop, and then it'd go bloop, but I mean, the DMV doesn't care about speed, so they get paid by the hour. Do you know if Walker is giving the actual Discord user the nickname? It is giving me something. So some of them are usernames, some of them are people's names, but people's names are oftentimes the usernames. So the Fisher, like whoever that is, and then I have to play a game where I have to guess which student it is, like the Fisher gal. I'm like, okay, so it's a woman, probably has Fisher in the name somewhere. And sometimes they use their first name only, sometimes they use their last name, and I have to play this game every week I do attendance. I have to connect the dots, and then I forget by the time I do it again, and yeah, so that's why we're doing this. Nickname might change during the semester. It could, in which case it would detect a new user, at which point I could Control-C out and hunt through the old one and update the record if I wanted to. So I could just edit I can come in here to students.txt and be like, all right, Big Hey Big is now Little Hey Big, right? And all the rest of the stuff would stay the same. So changing nicknames every 2 weeks like Shaq. Yeah, it's true. And but the thing is, it would detect it because a new student's been detected, which shouldn't happen because it's the middle of the semester, right? So That, you know, any new students detected are going to be name changes. And then I just have to, like, look at their new username. Okay, they're little, you know, okay, fine. And then I just go in there and edit it. It'll still save me a lot of time. The other thing I have to do is I have to sort it by last name, because that's the order that things are in Canvas. So Canvas is sorted by last name by default. And so I want to sort my students here based on, you know what, let me give these guys, like, actually, yeah, I'm actually going to remove the students file. I'm going to run it. And Big Honkin' Jones is going to be Bill. And the last name is going to be Kearney. And student ID is 1. First name for Jasmine is Jasmine. And the last name is Princess. I don't know. And Fidel Castro is, of course, Fidel Castro. And student ID is, of course, whatever. Big Hey Big, his name is Bryant. I'm just making up names, he's not really people. His student ID is whatever. Old Bailey is going to be Bailey. The last name of Jones. Student ID, whatever. E. Jones is going to be Edward Jones. Student ID, whatever. Okay, so if we look at the students.txt now, you can see that. Okay. So what we want to do is we want to sort this based on last name. All right, we got a couple Joneses. In fact, Big Honkin' Jones should probably be a Jones as well. Right? So we got 3 Joneses in here. Okay. And, okay, so how do we do this? We got 1 minute left, so I'm going to go over it because we're basically done. I just want to show you this last thing. If you need to leave, you can just pick up the last 5 minutes of this later. So if you want to sort a person, there's a couple different ways you can do it. The best way of doing it is like this. So you make a comparison operator, an operator less than. And that allows you to write code like you can say if you have a person, if you have like person 1 and person 2, you could say like if 1 is less than 2. So by default, C++ does not know how to compare 2 people. But if you define the operator less than, it does. And so it's going to take in a const person by reference P1, const person by reference P2. And now we need to say, what does it take to make one person bigger and better than the other person? And obviously the answer is height, right? Return. P1 dot last name less than P2 dot last. Oh, right. Friend. Okay. And so it takes in 2 people, person 1, person 2. And if person 1's last name is less than person 2's last name, then they're less. And so what this will do is this will sort alphabetically on last name. Okay. And if we have a tie, we'll handle that in a second, but let's just do this for the sake of argument. So then main.cc. And so the very bottom down here, after we've got all this and we're about to write it to disk, what we're going to do is sort the database from the beginning to... Oh, you do have a Zybox on Friday, by the way. Database.begin to database.end, which is on sorting. Like that. So because we have an operator less than defined for people, we can sort. Normally, if you told it, sort the people, it's like, I don't know how. How do you want me to sort it? First name, last name, Discord name, student ID? I don't know. And so if you want to tell C++ how do you sort a vector of people, well, you do this. And again, this is just kind of a pattern you memorize. It's kind of like the pattern for the operator less than. You just kind of memorize this pattern. And so given 2 people, what makes one person less? Last name. Now you might ask, like, well, what about operator greater than or operator... Nope, none of those matter. Operator less than. That's the only one that matters. So If you define operator less than, you can sort. That's the only one you need to do. Okay, so let's do this, and then we'll go over ties in a second. So if we run this code on week star, you see everything goes smoothly. Dim students.text, and you can see it is now sorted by last name. Fidel Castro's first, Habig's second, Bill Jones, Bailey Jones, Edward Jones. Now, these aren't sorted alphabetically, right? And so if there's a tie, I think in Canvas they sort by student ID. If there's a tie, I could be wrong. But I think ties are actually broken not by first name, but by student ID. So if I'm wrong, I'll adjust it, because this is a tool I'm actually going to use, right? So that's CC. So what if there's a tie? What if person one's last name matches person two's last name? Well, if that's the case, then we're going to sort them by student ID. Okay. So that's how you can sort. If there's a tie on the last name, then you sort based on the student ID. And if we wanted to sort on the first name, it would be first name here, but first names could be a tie also. So then you have to add multiple tie breaking steps like that. Student ID is nice because student IDs are unique and cannot be duplicates. That's the whole thing. So if I run it now, compile, run, you can see Castro, then we got Bill Jones, Edward Jones, Bailey Jones. Bill Jones has a student ID of 1. Edward Jones, that's wrong. Let's see here. Edward Jones has a student ID bigger than Bailey Jones. Are these both Joneses? That should be in the opposite order. It's a string. Is it a string? It is a string. It's doing an alphabetical ordering. Yes. You're absolutely right. You're absolutely right. Good call, sir. Good call. All right, so we'll story them. And hope it doesn't throw an exception. All right, there we go. Good call. All right, so run the program, then students.text, and there we go. It is now sorting them numerically rather than alphabetically. That's the downside to using a string, is that if you have a number in a string, it sorts it alphabetically. 3 is before 4, right? So good call. And there we go. That's the complete program. So I encourage you to watch the 12 o'clock class and see the process. It's really important for you to kind of get the process to coding down, right? There's a certain mindset, there's a certain approach to solving it. And if Bell hadn't told me the answer, what I would have done is I would have done this. I would have done it up in here and be like, all right, if there's a tie, we're going to see out P1, and start printing it out, and see out if one's less than the other and why, and and eventually we would crack the code. That's it. You guys have any questions about this? This program here takes as input a bunch of roster files and then combines together all of the people to file like this. So it's going to remember their first name and last name permanently. So even after I wipe these files out and put new ones in, these names and these student IDs will still be in there. It combines 3 and 1 and 3 and says Big Honkin' Jones has 7 days of attendance. And so I can automate 94 students worth of attendance every couple weeks. I can copy and paste them all into the server, run the thing, punch their grades in. It'll all be sorted in the order they are in Canvas. So I can just go 6, 6, 7, 5, 2, just bloop, 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 bloop. What do you guys think? This is real life. This is an actual program. This isn't like homework. Could make it a homework assignment, I guess. We're going to do Pokemon next, which will use maps. So that's another reason why I wanted to show this to you. It's because Pokemon 2 will use maps. Unless you don't want to. Okay. Maps are fun. Yeah, they're super useful. They're the single most useful data structure, other than vectors, probably. I use vectors like I use vanilla ice cream, but unordered maps are like the jalapenos you put on vanilla ice cream to make it spicy. No? You guys don't do that? Chili powder on your vanilla ice cream. Makes it hot. It's like something that G's Creamery would sell. You know, they have like all sorts of like spicy, you know, ice creams and stuff like that. I can't wait to make another map for you. So this isn't a map like an RPG map. This is, yeah, it's a mapping between a string and an integer. But yeah, Pokemon Part 2, we'll start that probably on Friday. Wednesday, just show up. Make sure you get all of your images loaded up into Google Drive. There's a certain format. You know, last name underscore last name underscore one, last name underscore. The Canvas thing lays out the file formats you have to upload everything into. You're going to submit your assignment on Google Drive, and then we'll just do like a gallery and just, you know, have judges, you know, Bell and other alumni will come in and we'll give grades, and yeah, it'll be fun. So no class per se on Wednesday. You're just going to be showing off your art and talking about your art. So make sure you show up, because we're going to be like, yo, how did you make this? And you got to like say, oh, well, I based my code on the French Impressionistic method. And, you know, so you're going to have to be here, you know, so you can like explain to us what you're doing, because that does affect your difficulty grade. You know, if you did something especially cool, you can kind of brag about it a little bit. Yep. But yeah, Wednesday is just going to be a fun class. Then we're going to start in on Pokemon 2 on Friday. And we're going to be using maps. So it'll be cool. All right. Thanks, you guys. And I'll see you on Wednesday. Good luck on the image processing. Have fun with it. And ask for help if you need it. All right, peace out.